In 4.3, we're going to talk about solving inequalities using multiplication and division. We're going to follow the same rules that we did in Chapter 3. So right now I have x divided by 5 is less than or equal to negative 3. I know that to get that x alone, because I'm dividing currently, I have to multiply so that they cross out. Again, if I multiply on one side, I have to multiply on the other side. So I'm going to get x is less than or equal to negative 15. And then I'm going to have to graph that, remember. So I'm going to find negative 15 on a number line. I'm going to fill that baby in because it's less than or equal to, and less means left. So I'm going to go to the left, and I'm going to have my inequality statement, and I'm also going to have my graph to solve that problem. Now for a problem where we're going to have to do division, let's do 6x is greater than negative 18. Okay, right now I'm multiplying the x by 6, so to get rid of it, to make that x alone, I'm going to have to divide by 6. So I have to divide the other side by 6, so I get x is greater than negative 3. I'm going to find a number line where negative 3 is. I'm going to circle negative 3 because it is not equal to it. And x is greater than, so I'm going to go to the right, and I'm going to graph my inequality. So those two examples were pretty easy. You just followed the rules that we did in Chapter 3. But there's another rule that you need to learn about when we talk about inequalities. When you multiply or divide by a negative, you must flip the inequality symbol, or sign, to make it remain true. So when multiplying or dividing by a negative, you must flip the symbol to make it remain true. So I'm going to give you an example. Negative x over 3 is greater than negative 4. Okay, I'm going to make sure that that x, that negative, it really doesn't matter where you put the negative, but you're going to want to put it with the number because you want the variable to be a positive neutral number for right now. Okay, so right now I'm doing x divided by negative 3 is greater than negative 4. Okay, I have to multiply by negative 3 to get that x to be alone. Okay, so I got to multiply both sides by negative 3. But because I'm multiplying by a negative, I have to flip the sign to the opposite direction. So instead of x is greater than, now x is less than, and negative 4 times negative 3 is 12. So x is less than 12. So I would find 12 on a number line, open it up, and go to the left. Okay, now let's talk about this. X is less than 12. So let's try a number less than 12. Let's try 10, just because 10 would be easy. Okay, so let's do 10 divided by negative 3 is less than negative 4. So 10 divided by negative 3 is going to be like 3.3 something, right? And it's going to be negative. Would that be less than negative 4? Yes. Let's try one that might be a little easier to do with math. Let's try 9. Let's say that x is 9, and that follows my rule that I have over here. X is less than 12. So if x is 9, 9 divided by negative 3 is negative 3. Is that greater than negative 4? Yes. Yes, it is. Because on a number line, negative 4 is here, and negative 3 is to the right of it. So that means it's greater than. Okay, so you can always plug your answer back into your problem to see if it makes sense. But the key here is this rule right here. If you multiply or divide by a negative, you have to flip the sign. You have to flip this sign to the opposite sign. So here's another one. Let's do negative 5z is less than 35. Okay, so I have to divide by a negative 5 to get my z alone. So because I divide by a negative, I have to flip the sign, and I get negative 7. So z is greater than negative 7. And then, of course, I would graph that. Z is greater than negative 7, so great means I go to the right.